Well, hi there, kiddos. We are going to solve some multi-step inequalities today, which is just going to take what we did in class today and just put it all together in one inequality. So we're going to solve them and then graph them. The first one we have is 2x plus 11 is less than or equal to 19. And so we're just going to use our equation steps and we're going to solve it. So the first thing we'll do is subtract 11 from both sides. So we end up with 2x is less than or equal to 19 minus 11 is going to be 8. That's an 8. I promise it's an 8. It's going to be equal to 8. And then I'm going to have to divide both sides by 2. And since I'm dividing by a positive, I don't have to worry about my symbol at all. So x ends up being less than or equal to 4. So when I do this on my number line, I go out to 4, 1, 2, 3, 4. And since it's less than or equal to, I have a closed circle. And because it is less than, I'm going to draw an arrow that goes to the left. So that's what my graph should look like. So let's look at number 2. Number 2 has variables on both sides. And so just like when we solved a regular equation with variables on both sides, we want to get all our variables together. And I always start by moving the one that is smaller. Well, negative 3x is smaller than positive 6x, so I'm going to add 3x to both sides. So I have negative 2 is greater than or equal to 7 plus 9x. And then I need to get x by itself, so I'm going to subtract 7 on both sides. So I end up with negative 9 is greater than or equal to 9x. And then when I divide both sides by positive 9, I get that negative 1 is greater than or equal to x. Well, this is one that is written backwards, so my variable's on the right. You have two options. You can read it backwards. If negative 1 is greater than or equal to x, then x is less than or equal to negative 1. It's written backwards. Or I can turn it around and write it as x is less than or equal to negative 1. I just flip all of the symbols around. And then when I graph it, since it's less than or equal to, at negative 1, I put a closed circle because it can be equal to negative 1. And then I draw an arrow to the left because you have to use the inequality in your answer, not the one you started with. And so it goes to the left. Now, number 3 is a word problem. It says 5 less than twice a number is at most the sum of 2 times the same number in 4. Well, let's just start with the 5 less than twice a number. That's going to be 2x minus 5 because less than is a flip-flop word. In order for something to be at most, that means that is the most it can be. It cannot be more. If it can't be more than something, that means it is less. And it can be that because at most means I can go all the way up to that number. So it is at most the sum of 2 times the same number and 4. So now I have to solve this, and I'm going to solve this by subtracting 2x from both sides. And what's going to happen is that my x's are going to cancel out on both sides, and it's going to leave me with negative 5 is less than or equal to positive 4. Now, way back when we were solving equations with variables on both sides, y'all would have told me this had no solution because you would have had an equal sign in the middle, and negative 5 is obviously not equal to 4. But I no longer have an equal sign. What this says is negative 5 is less than or equal to 4. Well, let's think about that statement. Is negative 5 less than or equal to 4? Well, yeah, negative 5 is less than or equal to 4. And since now I have a true statement, instead of saying this has no solution, I get to say it has infinite solutions. Because I can plug in any number you could think of, and it'll work. And so I get to say that it's all real numbers, so I get to draw that fancy R. Which means when I draw my graph, it just goes like this. And it just goes on forever in both directions because it is going to have infinite solutions. So now number 4, it's got some distributive property going on I'm going to have to deal with. And if you'll remember, this negative in front of this parentheses is like having a negative 1 there. So I'm going to have to distribute a negative 1. So I'm going to end up with 6m. When I distribute, that becomes minus 2m. When I distribute here, that becomes minus 3. Greater than or equal to 13 plus 4m. Well, I'm going to combine like terms. So 6m minus 2m is just going to make a 4m minus 3. And so now I'm going to do the same thing. I'm going to get my m's together. So I'm going to subtract 4m on both sides. And so now what I have is a statement that says, because everything's canceled out, I have a statement that says negative 3 is greater than or equal to 13. Well, since negative 3 is really not greater than or equal to 13, that's not a true statement. This is where I get to say that I have no solution, because there's not a number I can plug in that's going to work. So this one doesn't have an answer, because what happens is I have a thing that doesn't make sense at the end. Negative 3 is not greater than 13, so it doesn't make sense. It's not true, so I have no solution. So now let's talk about two more. We're going to do a couple of word problems. So number 5, Celia has at most $30 to spend at a carnival. Admission is $5 and lunch is $6, and each ride ticket is $1.25. We want to know which inequality represents the number of ride tickets X that Celia can buy. So the first thing we got to do is figure out the inequality. I know that she has at most $30. Well, at most $30 means this. So I know it's going to have to be less than or equal to 30. Well, that cancels out C and D automatically. I also know that to get in it's $5 and her lunch is going to be $6. Well, she's only going to walk in once and only going to eat lunch once, so we don't have to put an X with those. But the ride tickets are $1.25 a piece. So that's what my inequality should look like. So that should be answer choice B. Now we're going to take that inequality and we're going to solve it. Well, 5 plus 6 makes 11, so I have 11 plus $1.25x is less than or equal to 30. I'm going to solve this for x, so I'm going to subtract 11. When I do, I get $1.25x is less than or equal to 19. So I'm going to divide by $1.25. And I get that x is less than or equal to 15.2. Well, I have solved it. Now, we need to talk about what this means for the situation. For the situation, it means that she cannot buy any more than 15 tickets. At 15 tickets, she is done. If she buys 16 tickets, she doesn't have enough. But we're going to graph that. I've heard the number of tickets she can buy has to be 15. So to make it fit the situation, we're going to say x is less than or equal to 15. So I'm going to put my 0 here. And I'm going to put 15 right here in the middle. That's supposed to be in the middle. It didn't work out. And since it is less than or equal to, that means at 15 I get to color in my circle. And less than or equal to means to the right. I mean to the left. That's my other right. Point to the left because it's less than. So let's do one more. Diane wants to buy some new clothes for school. The shirts are $24 and the pants cost $40. Which inequality best represents the number of shirts and pants she can buy with no more than $175? No more than $175 means that she cannot spend a penny over $175, but she can spend $175, so that's less than or equal to $175. Well, shirts are $24, so $24 per shirt plus $40 per pair of pants has to be less than or equal to $175. So look at your answer choices. Which one matches what we just wrote? C is the one that works. So that is multi-step inequalities. Do not forget that if you are multiplying or dividing by a negative, you have to flip the symbol, but otherwise everything is good. And so we will practice this tomorrow, and I will see you then.